Welcome back to my channel. Now we study UP PGT Chemistry MCQs. 20 MCQs. Now we start question number first. Which of the following is paramagnetic? We know the nature of compound two types, paramagnetic and diamagnetic. Diamagnetics, which compound show the which have paired electrons. All electron is paired. But paramagnetic nature show in which have unpaired electrons, paired electrons and unpaired electrons. These unpaired electrons show the nature of paramagnetic characters. Like four examples are given in which the right answer is second. FeCN called 6 brackets minus charge 3. Like we try by solving these examples. FeCN or 6, we find the oxidation number of this question. F is X Cn or 6 Cn minus 1 and bracket minus 3. The X minus 6 is equal to these power of bracket come to equals another side is minus 3 and X is equal to these direction change and change this negative charge into positive charge plus 6 minus 3 X is equal to minus 3 plus 3. These are 6 or ये minus 3. The oxidation number of iron is plus 3. We know the oxidation number is 3 and in this condition atomic number of iron is 26 and configuration by these atomic number argons which have 18 and 4s2 20 and then 26 and 4s2 3d 6. In these conditions 18 20 and 26, these 26, but when the iron in 3 plus charge condition these becomes 23. Replacement by of the following we show 4s2 and 3d 6 conditions. In which conditions when we know that d orbitals contains 5 cells and which contain 6 electrons, and in these conditions these orbitals are removed from the chairs. 2 electrons and 1 electron removes and we get 3d 5 orbitals and these 5 electrons in conditions of 3d, and when these are strong ligand. We know the strong ligand Cn is a strong ligand. In this condition shifting of ground state to excited states, these unpaired electron shifted and becomes paired, and then we gets of conditions is 4 and 5 and 2 pairs of electron shifting and becomes paired, but one unpaired electron is remain in outermost cells, and these are unpaired electrons is character found in second options. This is right option, which is nature is paramagnetic. Due to the presence of these unpaired electrons, these compounds show the nature of paramagnetic. But in case of first, third and fourth, in 3 conditions, by the example solving by these methods by oxidation number we found that there are paired electron, all paired electrons show in these conditions, they show diamagnetic in nature. Fe minus 3 like similars, these Fe3 we keep its minus 4. In this condition we get Fe is plus 2 charge. When we get Fe plus 2 charge, the removal of only 4s2 electrons remains in this condition 4s2 electrons remain in this condition remains 3d configuration. Like similar we solve is plus 2 in this condition 4s2 3d 6. These two electron replace and we get 3d. These are 6 electrons like similar as, and these are paired up in the presence of strong ligands. These are paired up or these becomes in all pairs, all becomes in pair. So these are unpaired electron is absent, so this condition is dimagnetics. All examples similar this, like you solve and check out what is the nature of all complex compound is paramagnetic or dimagnetic. Okay, next, the oxidation number of cobalt in. So the cobalt, we find the oxidation of cobalt like as in K plus 1, cobalt is X, and CO, we know the CO is 0 oxidation number. Like similar as 0 equals opposite bracket charge is 0. In this condition X is equal to minus 1. The in this compound the oxidation number of cobalt is minus 1. Okay, next, clear. Oxidation number very easy. By proving this we find the oxidation number by this procedure. Next, vitamin B12 is coordination compound of. The coordination compound, the right answer is cobalt. The cobalt is vitamin B12 is coordination compound. The B12s may mostly cobalt plus 2 charges present in coordination like as a compounds. Next, which of the following act as pi acid ligand? We know single carbon to carbon and single carbon to hydrogen give sigma bond, but when we observe in double bond like similar as carbon to carbon, yeah, carbon to oxygen, in this condition we obtain 1 pi and 1 sigma bond. In these conditions all monoligands are all in condition nitrogen is uh, sigma bond, all three bond is sigma bond, pi bond is absent. In fluorines ions and oxygen to oxygen is sigma bond is absent, oxygen and combined minus 2 power charge. These are liberate of 2 electrons and these liberate of 1 electrons. In these conditions only right answer is carbon monoxide. These show 1 sigma and Y pi bond ligand. Next, question number 5. The first element of the rare earth metal is. We know the mostly some elements are rare metals are found in which lanthanum, uranium, actinium, and cerium. The right answer is cerium. The cerium is the first element of rare earth metals. Okay. Next, how many isomers of these are can exist? These are complex compound in which how many isomers? 2, 3, 4 and 5. The options are given. We know the isomers. Isomers are these compounds which have the atomic number is similar and the physical and chemical property change, which have the arrangement in changing arrangement, but the mass and atomic number is same. In this condition the cobalt NH3 का all 4, H2O का all twice and bracket plus 3 charge given. These compound, we know the isomers are two types: structural isomer, and stereoisomer. Okay, structural isomers are different types like as chain isomers, functional groups isomers, structures isomers, these are many types. Okay, but stereoisomers are two types. These are geometrical isomers and optical isomers. We know the optical isomers show only in the presence of ligands, different ligands. These show only optical isomers in डाई ligands, मतलब जो which show the pi ligands या डाई ligands. These show only pi ligand presence and या डाई ligand. Okay, but geometrical isomers show both monoligand and diligands compound. Both ligands show, which know the example like similar as these ligands are few examples of optical isomers like such as uh, uh, dimers isars AA or twice B2. In this condition A is diene, जैसे diene En is pi ligand. Besides or others show the en is equal to AA. It means A is pi ligand. In this condition, some common complexes compound are formed in this presence of ligand. These are best example 1 and 2. These are the tetrahedrals. In this condition, 4 ligands are in the present. These are diligands and these are the diligands of single. 2 to the 4 and 2 6. In this condition, these are hexagonals and these show the 6 ligands. In the conditions or other examples are given like as M, A2, B2, C2. In this are di ligands of 2, 4, 6. In this condition of 6 hexagonals. And like similar as M, A का all twice, B2, M, A का all thrice. These types of a complex compound are formed and to show off pi ligands presence of optical isomer. These are show optical isomers. These are mostly 4 and 5 types of complex compound are formed in optical isomers like similar as M A equal twice B2 and M2 B2 C2 M A equal twice B2 M A equal thrice. These are 4-5 types of ligand which show the optical isomerism. But in geometrical isomers show the monoligand and diligands, both types of complex compound, which are examples of similar like as M, A, B, C, D. In these conditions, both 4 ligands are different. In this condition, both 1, A, B, C, D, both 4 ligands are different. M, A2, B2. These are the coordination number 4. And in this condition, coordination number is 6. Only optical isomers show the coordination 6. But geometrical isomers show the coordination 4 and coordination 6. Both type of isoligand in the presence of mono and diligand. In this presence of only diligands. And in this coordination 4 MEBC and MA2BC. In this condition, 3 different type ligands. In this condition, and 2 mono ligands are different. Like as M. These are 3 types of coordination. Number 4 example of optical isomers which show coordination 4th compound. Like similar as coordination number 6. These are the show of geometrical isomers. These example are M A4 B2, M A4 BC, M A3 B3, M A3 B2 C, M A3 B C D, M A2, B2, CD, M, A2, B, C, D, E. These are different types of ligands and a range of monoligands in the presence of different conditions. But these different ligands completely coordination form of 6, 4 to 6, 4, 5, 6, 3, 3, 6, 3 or to 5 or 1, 6, 3, 4, 5, 6. 2 to 4, 3, 5, 6, 2, 3, 4, 5, 6. These are different ligands but show the coordination number of 6. We know example of Ma4P2. In this condition, the geometrical isomerism is formed in the cis and trans. Two conditions, cis and trans. Show the isomerism number is 2. And in these conditions Ma4B3 these likes to form of two isomers, and Ma3B2 these are form of two types of isomers, cis and trans. But Ma3B2C these form of three type of geometrical isomers. Ma2B2CD forms of five types. These are forms five types of isomerism, and similar Me2B26 form is four type. CD is form of four type geometricals, and Ma2BCDE are forms six types of geometrical isomers. These form six type of isomers, and these forms of nine types of isomers. These are different of geometrical isomers, and like similars we show the example of NS3 called 4. These are 4A 4, and H2 is B2, and M is metal, M cobalt, and ammonia is A, and water is P, Ma4B2. In this condition Ma4B2 these are formed cis and trans, two types of isomer. The right answer is two isomer can exist. And we all study in all full study of coordination compound, you learn all types of very easy to learning of optical and geometrical isomers, very important. Next, which of the following ligand will form a stable complex with lanthanides ions? Ln plus 3. We know the strong complex. We know stable complex form with the strong ligand. Strong ligand form uh, large metal, and weak ligand form weak metal. Okay, small metal form to stable complex compound. In this condition, if we takes strong ligand and large metal, small metal, in this condition the complex form is very unstable. So the necessary conditions to apply of that the strong ligands and large metals, and small ligands we take small metals. These two types are forms of the complex compound of stable complex compound. In this condition pH P3 phenolphthaleins, phosphine, phenolphthalein, 3 ions is a strong ligands. These are strong ligands, and lanthanides is a large metal. So these both combine to form of the stable compound. These are monoligands, and these are weak ligands. So these are not form stable complex with lanthanide, because lanthanide a large metal. The large metal combined with strong ligand and to form of stable complex. Okay, next, The oxidation number of central metal atom in Wilkinson catalyst is central atoms. We know the Wilkinson catalyst is what is its formula is PRH PP-S3 का all thrice chlorine. These are the rubidium phosphine का all thrice chloride. These are the formula of Wilkinson catalyst. In this condition, the central atom is RH. We find the oxidation number of RH. We know PPH all thrice oxidation number is 0. And chlorine is -1. We put these oxidation number. RH is X plus or thrice 0 plus minus का 1 equal to 0. In this condition, like as X all becomes portion is 0, minus का 1 is equal to 0, and X is equal to these shifted the here, these minus charge convert into plus, negative charge becomes positive. These oxidation number is 1. The right answer is 1. For the oxidation number of Wilkinson's catalyst, we learn this formula of Wilkinson catalyst formula. RH PPS का all thrice, 3 का all thrice and chloride. These are the formula of Wilkinson catalyst. The oxidation number is +1. Next, question number 9. Which molecule has linear structure? We know the different types of hybridization, sp3, sp2 and sp, like these are different types of hybridizations. In these conditions, show the different, these are tetrahedral hybridizations, these are trigonal hybridization, and these are show linear hybridization. These are given are, for example, CO2, NO2, SO2 and SiO2. In these conditions, the oxygen's molecules combine with carbons and to form of the linear sp, like linear structure of molecules. These are most CO and absence of non-pair electrons. These are absence of pair electrons. These are 4 only electrons combined with oxygen. So these are show linear structure. And 4s are electrons which are shared by the oxygen. So these are show linear structure. But all in nitrogen, sulfur, silicones, presence of unpaired electron besides of bondings. So these show the different types of the structure. Only CO2 show linear structure. Next, surface tension liquid does not depend upon. We know the surface tension is T is equal to F upon A. These are the depend upon temperature, intermolecular force and solute dissolving liquid. But the right answer is surface area. It is not depend upon surface area. The surface tension of liquid does not depend upon surface area. And temperature, intermolecules between the liquids and solute dissolving liquid. Which solute are dissolving liquid depend upon which category of solute, temperature, high and low, and intermolecular force between the solutes and solvent of liquid depend upon the surface tension but not depend upon surface area. Next, one of the modern method of studying for free radicals. We know the free radicals, uh, peroxides, etc. to give the free radicals. But or like others, electrophilics, nucleophilics are given. But the modern method of free radicals identified by is CIDNP. These are the CIDNP method for use of free radical study. Okay, these all three different methods are detections used of detection of wavelengths and spectrums of different compounds are different frequency and wavelength to travel. Okay, but CID-NP is another type of use for free radical study. Next, right order of stability of free radicals. These very important questions. We know the free radicals in this condition: tertiary, secondary, primary. These called third degree, second degree, and first degree. We know the third degree categories compound is more stable. We know the chain compound is less stable than is the branch compound. The linear compound is less stable than branch compounds, and these branch compound is third degree. When carbon to carbon attached by three others, these carbon attach other three carbons. These are third degree categories. And when two carbon attach with other two compounds, carbon, these called secondary. And when carbons attach with one carbons and not attached with carbon, these are called as primary degree. These are both primary degree. In these conditions, these are the primary conditions. The right answer is tertiary, secondary, and primary. We know the tertiary stable is free radical is more stable, and the right order is third option. Next, benzoyl peroxide when heated to about 80-degree temperature. We know benzoyl peroxide C6H5CO का O twice O2. These are the formula of benzoyl peroxide when heated 80-degree temperature. It gives free radical C6H5COO. And when two molecules of these obtained when these are breaks to remove of CO2, and these give C6H5 free radicals. The benzoyl peroxide is the base of the free radicals reactions. Next, the number of unshared electron on the carbon. We know the carbene ENE is obtained of double bond carbon to carbon when found of double bond. In these conditions, unshared electrons is number of 2. Next, select the most easily cleavage by the HBr. We know the hydrogen bromide when the reactions occurs to these compound. These are the peroxides of ethene. Ethene's oxide is combined with hydrogen bromides, and these hydrogen is break, oxygen is breaks and combining with one atom of hydrogen and one is bromine. And next, hemoglobin is a, we know the globin is like as a protein. These are a proteins. This right answer is a globular protein. Next, K2HgI4 detected ion. K2HgI4 detected ion. These called nasal resin. Very important name. These formula is learn. K2HgI4 is called national resin, and these are used for detection of ammonia NH4 plus ions. National resin used for NH4 plus ions detections. Next, the compound which is least basic. We know the acidic and basic natures. The acidic character to shows lithium, sodium, potassiums, the highly basic in natures. Basic compound are formed, and like similars of chlorine, fluorine, chlorine, bromine, iodines. These are form of acidic compound. But we know the more uh, basic compound is in which compounds. Fluorine is highly electronegative, and nitrogen is electropositive compare of all hydrogens and oxygens compound. These hydrogens and oxygens compound is nitrogen is highly electronegative. and these are forms of the basic nature of compound and F3. Next, the established among the following carbocation. We know the long chain, when the long chain hydrocarbons free radicals obtain, these are the less stable. These long chain hydrocarbons free radicals is carbocation is less stable as the compare of short carbocations. In this condition, the right answer is these benzene rings and contain only one methyl free radicals. In this condition, these are most stable carbocations in the comparison of all example. Next, the there are the given of one equation. In this condition, these are called toluene. Toluene in the presence of Hv heated gives to this product of benzyl chloride. What is the presence of? We know the replacement of hydrogen, addition of chlorine is called chlorination. Is right is Cl2. This options is Cl2 and this chlorine is add. Next step, we know these chlorines react with K to form of minus KCl and these CN group attached to the methyl group and to form the these are toluene and benzyl chloride and these benzyl cyanides. These are formed. These are right. And next, these are formation of CS3 COO group. These CN groups the replacement of nitrogen and these carbon convert into carboxylic groups. We know when try to hydrolysis in the hydrolysis processes, these C groups convert into COOH groups and this compound is formed. So these are four options given in this. The right answer is first. In first options use chlorine Cl2 and second product is formed CS2CN and third is hydrolysis of waters. These are the right answer. These are very important 20 MCQs and repeats in all competitive exams. And so you learn and practice good. Thank you very much and like, share and subscribe.